Hi all. In this video, we are going to discuss about the practical implementation of compilation process. Now, in the earlier video, we discussed more in detail about how the compiler works in Java. So, the illustrated view of compiler workflow we have seen in detail. In this video, my focus is to demonstrate how the compiler actually applies that workflow in order to compile your Java source code. So for that, the first thing that I would like to explain here is I have created a directory named java-demos. If you notice here, this particular directory is pre-created by me, and it is kept empty. Okay, right now I don't have any files internally to that directory or folder. Now this is a Mac view. Okay, the folder structure what you are seeing here is a Mac operating system, Macintosh operating system view. If in case you're working on Windows, you need not worry. It's going to be more similar. You're going to access your D drive or E drive and create one folder similar to this, like java-demos. It's up to you what name that you want to give to the directory or the folder. But in my case, I've just created java-demos. Now what I'm going to do is I'm going to create a snippet of code using Java language, and I'm going to make sure that is represented as a source code. Okay, so source codes are human readable, right? Then we have to hand over the source code to the compiler. So here we are expecting two files that gets generated in this empty directory. One, your source code, that is .java. After creating the source code, you need to hand it over to the compiler, and the compiler will generate it as a .class upon successful compilation process. So we need two files. Once the .class is generated, which we call it as a bytecode here, we will be handing over that bytecode to the Java runtime environment, where the JVM steps into that environment and helps us in interpreting that .class to the corresponding machine where we are running the .class. It interprets the code to the machine understandable. Anyways, that we will see a bit later. But right now, this is the kind of a demo that we are going to see right now. So what I'm going to do is I'm going to launch a text editor. Okay, it's a text file. In Windows, you will be having Notepad. In my Mac operating system, I have a text edit app, and using that, I'm going to code the Java. So what I'm going to do is I'm going to start with import space java.lang.star. Okay, so this is just a structural view of a Java file. So we start with import statements, but the one that I'm using right now is a default package. Default package means we need not import that package. By default it gets imported, but just for demonstrative purpose, I've just added that import statement to give you a structure of Java code. Now this is more similar, like in C and C language we use hash import, stdio.h and so on, right? The same way here. Now the next line that I'm going to do here is class, and then space. I can give a name called greeting. So greeting is the name of the class. We will discuss all these structure of code more in detail later, but right now it's just to understand I've created a class and a class name. So in Java, is that mandatory to create a class in order to write a main method? Yes, of course. In Java it is mandatory. You have to use the greeting class, and then you need to write your main method. So means without a class you will never see any code in Java. So there is no hang around of functions isolated from the Java class. You need to write it inside the Java class, right? So public static void main, and here the argument is going to be string args, and internally to this method I'm going to write the sysout statement, system dot out.println. So if you look at this code, if you're if you're already familiar with C or C language, it looks more similar to it. So even C language has a main method, which is an entry level method. C++ has an entry level method. C# and .NET has entry level methods. The same way here in Java also we have an entry level method, and that's none other than your public static void main. So hi, welcome to skilled. Okay, so I have this snippet of code written, and I'm going to voluntarily make a mistake. The end of line statement need to be ended with semicolon, which I'm not applying the semicolon there. Is a voluntarily giving that mistake. It's because we need to see if the compilation is success or not. So in that case, let's keep this line with an erroneous statement. So a class, a main method, and inside the main method we have the sysout statement. It's more similar like in C and C++, or in C++ we use cout statement. In C we use a printf statement. So the same way here we have system.out.println. So you need not worry upon these snippet of codes right now. If you feel like it's a little uncomfortable to understand each and every line, it's okay. Right now it's absolutely fine. You will be learning all these stuffs in the future videos step by step, but right now just to explain you what the compiler does in the Java environment, I just wanted to write this snippet of code. Okay, now let's go ahead and save this file. So I'm going to save this file straight into the java-demos, which is directory I created, a pre-created file, and I'm going to give the name of the file as same as the Java class name. The class name that we have kept there is greeting, right? Hope you can see that. So here it is a greeting, the same way I'm giving greeting. In our earlier video, we understood the extension of the source code should be of .java, right? The same way here, we need to give greeting.java. So that becomes a Java file, Java source code. You can save it, and you can go straight into the directory and see the file gets created. So what technically happens here is we created a source code in a text editor or in a notepad. In your case, if it's a Windows, you can use notepad. If you are using Mac, then obviously you know how to access the text edit app. So this greeting.java is a source code of Java language. Source code, Java source code, right? This Java source code need to be handed over to your compiler. You need to hand it over to the compiler. The compiler, the Java compiler, I mean it's a Java compiler. The Java compiler will in turn make use of this .java file as an input file, and they process that input file by scanning line by line and see if there is any errors are there, which can be tracked at the compilation time itself. If it could not find any errors, then obviously the compilation is successful. Upon successful compilation, it will generate a .class file, and the .class file will get placed here in the same directory from where you are trying to compile the source code file. Okay, if in case there's an error, then your .class will never get generated. So in our case, we have did a volunteer mistake. Let's see what's going to happen. So for that, I'm going to launch my terminal window. The terminal window, you keep an eye on this space. Okay, you have to keep your eye straight into this space once I hit the Java C command. The reason is it will populate with one .class file. Okay, you can see the pop-up of that file in the specific space. Now this is a terminal screen in my Mac operating system, but in your case, if you are using Windows, you'll be using command prompt. Now I'm going to hit a command called pwd, which is print working directory, to know what directory that I'm right now, to confirm you that I've already moved up to the directory called java-demos, and that's what is reflecting here. You can see that. So I'm straight into this directory, so means I'll be able to access this greeting.java right now, right? So let's go ahead and say ls. I'm giving ls command. With that, you can see greeting.java is displayed, means this greeting.java is there inside this directory. That is a meaning. Now what we can do is we can invoke the compiler. Compiler have to be invoked via java c command. javac command will help us in calling the compiler, but the compiler have to be called by providing the input file. So which is going to be your input file? The input file is none other than your greeting.java. Yep. If you have spelled it, yes, of course it's correct. So if you are reading along with me, you can catch it up, right? So it's good. Greeting.java. Greeting.java is the input file to this command javac. So once that input file is given to the compiler, and if you hit enter, the compiler starts doing its process of compilation step by step, line by line. The compilation happens. Equivalently, if every line is successful, then the compiler will come out with an output file, which is a .class file. So let's see if that .class file is getting generated here. So I need to feed in the input file as greeting.java and hit enter. As I said, you have to keep your eye straight into this directory space and see if there is any .class file gets generated. This time, obviously, it's not going to happen. But anyways, you can keep an eye on that. The reason why it is not happening is the Java compiler is yelling at us saying that, hey, listen, you have some mistakes in your code. Try to resolve that code mistakes and then you give it to me so that I'll be happy to compile it. So I have to go back to the code and to read the error message, let's say it's somewhere in the line number 7. The error is semicolon is expected, but obviously we have skipped that placing of semicolon on this system.out.println statement. So it's mandate that we have to apply semicolon. Otherwise, compiler will never ever allow us to see the .class file generation. It won't complete its compilation process. So all the line by line errors have to be resolved by the programmer or the coder or the developer, whomever it is. They have to go ahead and resolve that error first before they see the .class file generation. So now what we are going to do is, again, let's launch the folder structure first and then the terminal window. Let me clear out the screen. Since I have placed the semicolon, I've saved the file. Okay, I just hit the Control S, the Command S, but in your case, you can do it either way. Please ensure that every time you make a change on the code, it has to be saved. If you forget to save it, then obviously the error will persist again. So let's go ahead and use javac space greeting.java. Boom, here it go. So we have this .class file got generated. You can see that if you have kept your eye straight into the space, you would have seen a generation of file would have happened, and that's none other than the .class, which is technically we call it as a bytecode. Now what we are going to do with this bytecode? Who generated this bytecode? The bytecode is generated by the Java compiler. What is this bytecode is actually? It's an intermediate code. Why I'm calling it as an intermediate code? Because it is not the direct machine understandable format. This is not a machine understandable format. Okay. Further, the JVM have to step in. The JVM have to step in, and the JVM have to understand this bytecode and interpret it to the corresponding operating system. It could be a Windows, or it could be a Macintosh, or it could be a Linux environment. The JVM have to do it. Anyways, that study is which we are going to see in the next video. Right now, I'm going to check out this code to this JVM environment. So I'm going to initiate the runtime environment using the command called Java. Before it was a compile time environment using a command called javac. But right now it's a runtime environment with a command called Java. And we need to forward that class name. Don't give .class. While you're running, you should not give greeting.class. Just give Java space the file name. What this Java command will look out for that greeting from the greeting is the .class automatically. If the .class is present, it will allow us to execute the code. Otherwise, it will say, hey, I could not find out any .class file. So if I hit enter, you can see, hi, welcome to skilled. That's the desired output that we wanted from this snippet of code. And that's what is happening. So what you have to do right now is you either use your specific platforms of editors, either from the Mac or from the Windows. Open the text editor, give the snippet of code, and then save them with the source code extension called .java. Hand it over to the compiler. Compiler will compile it, and then produce a .class, which is a bytecode. It's an intermediate code, and that's why Java is called as an intermediate language. It's not a compile language alone. C and C++ are compile language because you compile it and hand it over directly to the mission code. Mission understandable format. The compiler will generate the mission understandable format and you can directly run them into the respective mission. But they are platform dependent, right? But here in this case, it's not that way of output. When you compile, it only generates a bytecode. The bytecode is an intermediate code between your the mission code and the source code. So it has to be handed over to the runtime environment and they have to interpret it. The JVM have to interpret the code to the respective operating system. So that's why we call it as an intermediate language. Now the execution is successful. What I would like to show you is the greeting.class. So if you look at the greeting.class, let me open this. Let's say if I could open in some text editor format, so that we will have some space to understand how this particular code might look out with. So let's see if I have some text edit app, open them. Obviously we cannot understand because it will be a little bit of junk. Okay, few things probably, yes, of course we can understand. We have some print stream, println use. The library that it is using is Java lang library, and this is how the object creation happens, and a lot of blah blah stuff is there, and more of a Greek and Latin summation symbols and stuff like that. But this is not required for us to understand. Probably the bytecode is understandable by the JVM. JVM can take care of it. Further, this have to be converted to zeros and ones, and that's when we need JVM. JVM will interpret this code, this bytecode what you're viewing right now, into the mission understandable format. Okay, so that's what I just wanted to convey in this particular video. So in the next video, we're going to see more advanced understandings of the Java architecture, and that's going to be a little more animated. So keep awaiting for the next video. So thank you so much for your time. Have a great day, and we'll connect up in the next video. Thank you. Bye.